Thank you everybody for joining the session. And our today's webinar, it's on innovative hex meshing functions in FEA for complex model simulations. Today's session will be presented by myself, Rajshekhar and Mohan. And with me, I have Paresh and Aditya, who will be performing all the demos. Firstly, DEP stands for Detroit Engineering Products. We were founded in 1998, and we are the creator of the Meshworks platform. We have in-house R&D team and also a global presence. Our headquarters, it's in Troy, Michigan. This is the group which is actually the creator of Meshworks platform. And all the software development on Meshworks is carried out by our software development. Next is our product development group. This vertical actually carries out new product development. You can provide us your requirement right from sketches all the way up to the prototype testing and the final product release. DP has a good skill set which can, achieve all the product developments. Next is our talent acquisition group. This group takes care of all the on-site placement requirements. Suppose if you guys need some good talents for any contract roles in your organization, you're always welcome to reach us out. And this group can fill the best talent in the market who will fit in your requirement. Coming into the DP's team, we have a headquarters in Troy, Michigan, and we have around 160 employees in North America. We do have our own office in California. In India, we have offices in 3 locations and we have around 300 employees. In China, we have our own office in Shanghai, which has 30+ employees. In Tokyo, we have 4 employees, and we do have our distributors, which is in blue colors. In Europe, we have a presence in Germany, Italy, France, Poland. In Korea, we have a distributor. In Japan, we do have our own office and also a distributor in Yokohama. We have a team of around 500+ engineers globally. Out of which 20% is PhDs, 70% masters, and 10% are bachelors. What is Meshworks 2021? Meshworks 2021 is our software, which is a CAE parameterization tool, which helps to convert the FEA and CFD models into intelligent parametric designs. So once a design is parametric, we can perform a lot of design iterations and DOE studies with the help of Meshworks. Next is our morphing technology. With the help of Meshworks morphing process, you can expect upfront design solutions on CAE and CAD models. With the help of morphing technology, you can very well have a good relationship between CAD, CAE, and again CAE to CAD, kind of a rapid collaboration, and we can have quick design updates. And in fact, the CAE team can very well lead the design. Next is our design optimization capability. With the help of Meshworks, you can easily perform multidisciplinary optimization. It is actually facilitated by the parameterization and morphing techniques, which you will actually perform in one solver environment. For example, if you prepare your parameters in a Nastran model, all the parameters can be directly transformed into other solvers, for example, Abacus or Dyna, or to your CFD model, timing, with the help of transformation functions within Meshworks. So multidisciplinary optimization with multi-solver environment can be nicely handled with the help of Meshworks. And recently, all our customers are looking for a good amount of time reduction on their day-to-day work. This actually initiated process automation at our client locations. In fact, in the recent days, we have created a lot of process automation at our customer locations. And today, as we speak, each of these customers are getting 70 to 80% of time saving on their repetitive process. Next is our pre and post processing capabilities. Meshworks is a pre and post processor. It has all the features of meshing, morphing. It can prepare the FE models for the regular simulation softwares like Nastran, Abacus, Dyna, CFD, and it has the pre-processor which can post-process all the results. It also has integrated batch meshing modules, which can mesh all the components to the best quality. And with all the automated tools, you can quickly assemble your models. So a lot of time saving can be achieved by using Meshworks in your pre and post processing requirements. Next is our ConceptWorks tool. This is one of the latest capability which we have released to our customers. With the help of this tool, you can create a lot of new concepts and architectural changes within a very short time. In general, if the new concept generation with a regular or the conventional approach, if it is going to take, for example, 4 weeks, the same can be achieved in 2 to 3 days time frame. So you can think about a 10x kind of a time reduction by using Meshworks on your conceptual design development. Next is our Meshworks application at different stages of the product development. The curve here shows the current trend and the new trend. And by using Meshworks in the conceptual stage itself, you can take a legacy model and you can start working on that to morph and fit to the new shape requirements, styling requirements. And then you can parameterize the model and perform DOI optimization in the conceptual stage itself. So all the heavy loading will be done in the conceptual stage. And when you go to the detailed evaluation stage, you will have minimal number of iterations to be performed in the design. So at the end of the validation and maintenance phase, you will have pretty much the design meeting all the requirements, which in the other case of the conventional process, you need to spend a lot of time in iterating, which includes the CAD design change or meshing changes and a lot of time involved in the process. So if you see the variety of tools that will be applied for each of these works in all those tools will help you in the conceptual stage. And in the detailed stage, you can apply the other tools of automations for developing the full vehicle models. So coming into the Meshworks solution for Hex Meshing, we have a lot of tools which is not available in the conventional softwares. First is our automated Cartesian hex mesher, which allows you to create 100% hex mesh for the complex parts. Second is our extruded hex mesher, which can rapidly generate the Hexadominant meshes in a specific direction. The third one is the thin wall hex mesher, which can quickly convert your midplane mesh into a quad dominant hex meshes. And using all these functions, we can assume that any complex geometry, once it is brought inside Meshworks, can be converted into a Hexa mesh model with minimum number of pentalements and with very less amount of time. We do have a lot of automated functions that are available for the users to create exception quality mesh. So our team will kind of touch up on all these functionalities over the next few slides. And many occasions on Hex Meshing, you will ideally start with a condition where virtually no CAD cleanup. That's a big advantage of using Meshworks.
Okay. Raj. So thank you for the introduction. So from here, I will take on all the demo sessions. So the first one that we will be looking at will be the bumper foam offset and the auto hex mesh method. So as you can see, we have a slice of bumper foam, and then we've gone ahead and created a midplane mesh using one of our auto midplane mesh method. So once we have created the midplane mesh, our next set will be to offset the plane. So we will go ahead and just select and create an offset. It will quickly go ahead and offset and create a core mesh. So this core mesh will be used to create a hex mesh. So once the CAD geometry is being used to create a skin mesh, we will go ahead and select it, and we will provide the element size, and then we will go ahead and import the core mesh. Once the core mesh has been imported, we will select the core and then simply go on plastering auto hex mesh technique. Quickly go ahead and generate the hex mesh with the use of the core mesh and this. If I take a cross section, you can see how nicely it's gone ahead and generated the hex mesh. This entire auto hex mesh process requires minimal manual effort, and you can see within like a minute or two, one will be able to generate a good quality hex mesh. So the next one will be the extruded hex mesh with the projection method. So just say once we have our input CAD, again we can use one of our auto mid-plane meshing technique, and then we will go ahead and offset the mid-plane mesh. So you can see how in all the T junctions it's gone ahead and done a very neat offset. We will similarly create a skin mesh. We will go ahead and import the core mesh into the skin mesh that we have just generated. And then once we click on the auto hex mesh, it will very nicely go ahead and add an additional layer. And then to the geometry, it will very neatly go ahead and plaster it. So the next one will be our auto extruded hex mesh. So this is a very nice technique and a function that Meshworks has. So just say you have an input CAD data and you want to very quickly generate it using one of our extrude method. The first step is we just go ahead and create a skin mesh like the one that you're seeing in front of you. So once you've done a skin mesh, you can go ahead and create your extruded hex core elements. So before that, we will just go ahead and identify some of the features, and then we can go ahead and organize it into different PIDs. So once this is done, you do an FE feature conversion into CAD curves. So this is another function that Meshworks has, where you can just project your CAD curves and then you can create a surface using the CAD curves. So once the CAD curves has been created, the user can go ahead and create a mesh onto the CAD curve. So you can see it very nicely follows the CAD curve features. And then we select the planar mesh, and then we specify each and every position that you want your core mesh to be generated by selecting a node in every sector. And then once you click on the parametric extrusion, you can see your core will be very nicely generated. This is with respect to all the inputs that you which will be the position of the nodes in every sectors. So this will be the output of your core hex mesh. So again, similarly, you can use this core to run your auto hex mesh. So this is how the parametric extrusion works. So the next one, we will show you the Cartesian method. So once we have the CAD input, this particular CAD is like a hollow CAD. You can see once we do the skin mesh, we can just go ahead and organize the mesh into different PIDs with respect to the face. And then we simply go ahead and do the Cartesian generated hex mesh. See, very quickly, it will go ahead and generate a core mesh for you with respect to the element size that the user has given. And simply by just selecting the core, the auto hex mesher will take care of the projection process, which is the plastering technique again. And once we get the output, you can see how nicely the core mesh has been plastered onto your the skin mesh. So all this just takes a matter of minutes for a user to generate. The user doesn't need any formal training. It's just you just generate a skin mesh, and then you generate your core mesh, and then you carry out your auto hex mesh to get the final output like this.
So we will go ahead for the next demo. So now in front of us, we have a caliper model. So the base input, so we will be creating a hex mesh from this caliper input. So from the CAD, or even if you have a 2D mesh, a user just wants to create a 2D face or 2D mesh, which will capture all the features onto the CAD. Now, once we have the 2D mesh available, what we're going to do here is, as it is a symmetric model, we will cut it into half. That's our next step. So once the once the CAD has been, or once the mesh has been cut into half, then we will go ahead and do the meshing. And as we can see here, this is a typical complex geometry. So we will go ahead and split this particular mesh into 3 different parts, as we can see here. So you can see the bottom part has nicely been trimmed, the middle part and the top part. Now we will assign it as zone 1, zone 2 and zone 3. Now we will treat each and every zone as separately and create a hex mesh from it. Now in front of us we have the zone 1, and what we did here is we have organized the skin mesh based onto the features. Skin mesh has been organized. What we're going to do here is we will imprint all the features onto a single plane so that everything will be in a unidirectional. So once the features have been imprinted onto a single plane, then we will go ahead and create the 2D mesh. So this is how we will go ahead and create the 2D mesh, and that will drive your final output of the hex mesh. So the next click of a button is nothing but extrude the hex mesh, and this would be the final output which we'll be getting for the zone 1. Similarly, we will do the same process for the zone 2. Again, this is not the final hex mesh. This is again the core mesh, and we will follow the last step as the final hex mesh output. Now here we have the CAD, we have the 2D mesh. We will go ahead and organize all the features into different PID with respect to the feature angle. Then we will imprint very nicely the features onto a single plane, and then we will go ahead and mesh that particular CAD curves. So this will nothing but drive your final hex mesh output. And then by just click of a button, extrude, this would be the final hex mesh output for the core mesh. Similarly, as we can see here, this is a complex geometry where you can see there is a hole here, there is one more hole here, but irrespective of the features, Meshworks will nicely go ahead and do the meshing for us. The process is again the same. Organize a skin mesh based on the features, imprint all the features onto the single plane, create the mesh. If you want to create a washer layer for the respective hole, you can go ahead and do it on the mesh level. And then once you click on extrude, that would be your final output. That nicely created the washer layer. And if you see here, it is, instead of circle, it is, for now it is square, because again it is nothing but the core mesh for now. Now what we're going to do here is we will bring in the zone 1, zone 2 and zone 3, and we will combine it both by using an equivalence. Then we will go ahead and reflect it so as to get the entire caliper model. This is the initial core model. As we can see here, there are a lot of sharp edges, and then the next input, as Aditya showed us, is just bring this particular core model into the with respect to the outer mesh, and simply click on auto hex mesh. Once you click on auto hex mesh, automatically with respect to the plastering technique, it will very nicely go ahead and create the final mesh output where all the features are nicely been captured and it is been nicely smoothened out. So this is how quickly a user can create a hex mesh by using Meshworks tool. So the next demo here is rolled hex mesh. So in front of us, we have a stent model on a 2D mesh. So whenever we get a CAD with respect to our Meshworks 2D mesh tool, we will go ahead and create a mesh onto this particular 2D surface, and we will go ahead and reflect it with respect to get the entire model. So to do this particular mesh, it just requires like 2 to 3 minutes. Automatically, the mesh will be created. This is nothing but the 2D mesh for now. So the next step is nothing but we have a nice tool that is called as a planar to cylinder, where a user has to select the 2D elements. Then a user has to define the axis for the rotation. Once the axis has also been defined, a user has to define the thickness and number of layers. So automatically by click of a button, a planar mesh has been converted into a cylinder. with respect to the thickness and the number of layers which have been given. Now here, automatically Meshworks will identify the thickness, and there will be no penetrations or intersections, and this is an entire automatic process. So this is the final output of a stent model. Now we have a hexa solid fuse. So most of the time, whenever you have to fuse two hexa models, it is pretty difficult. But in Meshworks, we have a nice tool that is called an hexa solid fuse, and you can fuse the two hexa model quickly. So here in front of us, let's assume that this is a single model and we need to fuse it. So we have a planar mesh, and we have done the meshing separately for that particular planar hexa mesh. And then there is another feature which is coming up, that is circular. We have meshed it separately. Now, as you can see that there is no imprinting done yet onto the base surface. And you can see on the other side also the mesh is pretty clean and good. Now what we need to do here is a user just has to select the master component and the slave component. That's all has been needed just to fuse the two hexa models. And automatically two hexa models have been fused, and you can go ahead and use it as a final output. You can see how nicely it has been imprinted onto the base surface or the base hexa meshing, and it has gone entirely through the thickness too. This is how quickly a hexa mesh model, hexa fuse works in Meshworks. Now we have a hexa mesh imprint onto a tire print model. So before that, let's assume that we have a CAD geometry in front of us. Now we have a very nice tool, process automation tool. By using that, we can go ahead and very nicely create a quad dominant hexa mesh model in front of us, and this would be the final output. So to go from the geometry till the hexadominant mesh, it just takes around 30 minutes, and we will get a very nice smooth final output. And then after a click of a button, we will get a very nice 360-degree hexa mesh tire model. We also support the winter tires. Well, if the features or if the pattern is pretty difficult, we can go ahead and create this kind of tire print pattern too. Now I'll quickly show you what if you have an existing tire trend pattern and you have to imprint a new features onto this tire trend model. So we have a tool that is called as an Hexapropagate. Now in front of us, we have a tire trend model in front of us, and whatever 2D face, this is nothing but the 2D face. So these are nothing but the elements or the features which we need to imprint onto this hexa model. So for that, the first step is to select the source mesh. That is what I will be selecting right now. And now I will hide my source mesh, and I will show you this is nothing but the hexa mesh. I have just taken the face of that base hexa mesh model. Now I will also select the face of the hexa model and simply click on hexa imprint or propagate. Automatically Meshworks will go ahead, identify the thickness of this particular hexa model in the background, and it will nicely create the final hexa mesh model output for you. This will be very useful whenever you have a change in tire pattern or whenever you have to imprint any features onto the pre-created hexa tire thread pattern. It will also go ahead and nicely maintain the cross sections too, so that you don't have to go ahead and do any other steps. Now the last one is HexaBolt Creations. So whenever a user has to create a 3D HexaBolt, we have an automatic tool in which a user just has to select the two components. A user can select the entire assembly, and directly by just one click of a button, he can create all the holes in your model. But for now, I'm just showing you how it has been created onto two components for now. So user has to select the two components, and then a user has to define the unthreaded part. So by just this particular information, automatically Meshworks will identify how many holes are there in this particular model, and it will only highlight the holes, the bolt holes. So these are nothing but the bolt holes in your model. Now, with respect to the table here, we will define the bolt size. So let's say we need an M6, we can change the shank diameter, we can change the shank length, and just click on create. Automatically Meshworks will very nicely go ahead and create a 3D Hexa model. Not even that, it will go ahead and create contacts too between the bolt and the connecting components. It will also go ahead and create very nice pretension surfaces. So user has to define whether you want it in the mid or any layers. With respect to that, it will nicely create the pretension surface, and also auto contacts are also been created. So this was all about today's demo. By using Hexa Mesh, by using Meshworks, you can create Hexa Mesh quickly. Now we want to highlight some key propositions in the Meshworks. So obviously there is a drastic time reduction for Hex Mesh model, and we can achieve from 50% to 80% of time reduction. Using our parametric technique, we can convert this FE models to intelligent parametric FE model. As we all have seen, by just click of a button, we can get automatic Hex Mesh. Even if we have a complex geometry, we can build Hex Mesh easily using Meshworks. This will help to achieve more accurate FE results. We can also create process automation, which will reduce up to 2x to 10x time in your process time. We can also create a parametric file, which will be helpful if the model changes slightly, so that the user doesn't have to mesh the Hexa model again and again.